Question 9. Let mxt and myt be the moment generating functions of two random variables x and y respectively. If expected value of x is 1 by 2 and variance of x is 1 by 4 and the MGF of y is given as the MGF of x multiplied by some expression, then what is the variance of y? So many student, or we can say most of the student, will try to find the variance of y with the derivative method of MGFs. So that will take a lot of time, but we do not need to do this question by that method. How we can do this question in very less time? Now focus here. This moment generating function of y is given in terms of moment generating function of x. Now, if we assume that this is also a MGF of some another random variable, now let us write that this myt is equals to the product of two MGF. The MGF of z is given as mzt. If mzt is given here like 0.75 plus 0.25 e to the power 2t. So what kind of variable z here? If we define z as this one, suppose z is taking two values 0 and 2. And what are the probabilities? Suppose probabilities are 0.75 and 0.25. So this is a valid probability distribution. Why? Because the sum of probabilities is equals to 1. So this is a valid probability distribution. How do we find the MGF of discrete variables? If we are given the probability distribution like this one, so the MGF of Z will be T1 e to the power T into the value Z1 plus T2 e to the power T into value Z2. So value of Z1 is 0, value of Z2 is equals to 2. So this is the value of actually Z1. This is value of Z2. This is the value of P1 and this is the value of P2. So P1 is 0.75 e to the power T into value of Z1 is 0 plus P2. Value of P2 is 0.25 e to the power T and value of Z2 is 2. So this will be equal to 0.75 plus 0.25 e to the power 2t, right? So this is the MGF of Z here. So this MGF of Y is the product of two MGF. We can say that the Y is the sum of two independent random variables Z and X. Why? Because if Z and X are independent, then the MGF of their sum will be equal to the product of their MGFs, right? So the MGF of Y will be the product of these two MGF. X and Y are independent random variables here. So now we need to find the variance of Y. So variance of Y will be variance of z plus x. Z and x are independent, so we can write variance of z plus variance of x. We know that variance of x is given. Variance of x is already given here, 1 by 4. Now we need to find the variance of z. So using this probability distribution, we can find the variance of z. How? Expected value of z will be 0 into 0.75 plus 2 into 0.25. So the expected value will be 0.5. Now expected value of z square. 0 square into 0.75, 2 square into 0.25. That will be 4 into 0.25. 4 into 0.25 equals to 1. So the variance of z is expected value of z square minus expected value of z whole square. So this will be 1 minus 0.5 square. So this will be 0.25. If we subtract 0.25 from 1, we will get 0.75. So the variance of z is 0.75. So on the place of variance here, in variance of y here, we can write 0.75 means 3 by 4. So this sum will be 1. So the variance of y will be 1. So option C is correct. Now let us revise the question again. The MGF of y is given as the product of two MGF, where this expression is the MGF of z. By seeing the MGF of z, we can say that the probability distribution of z is 0, 2 and 0.75, 0.25. This is a valid probability distribution. So if this MGF of y is the product of two MGF, that means y is the sum of two random variables z and x, and z and x are independent. Why? Because their MGF of their sum is equals to the MGF product of their individual MGF. So the variance of y will be variance of z plus variance of x. Now variance of z can be calculated from here. That will be 0.75, and variance of x is given already here. That is 1 by 4. So we will get 1.